Alrighty. Hello everybody. So in this presentation, this video, I'm going to be going over estimating the cost for concrete pad. This activity 211. Connections that I want you to make with this is try to apply this to our model house that we've created. Think about in terms of materials if we were to create a scaled down version of a concrete pad, what type of materials would we end up using? Think about how we would set this up as well and come up with some ideas, some creative ideas of how we could end up maybe implementing this for our scaled down house. But anyways, this is for estimating the cost of the concrete pad. So in terms of concrete estimating, what are we going to be talking about? The common uses of concrete, also reinforcing bar, which is called rebar. We're going to determine how much the concrete is going to actually cost. We're going to estimate the cost of a pad. And then we're going to talk about what a cost estimator is. Now, some common uses of concrete. We've seen them in many different places. For houses, we've got it for the foundations and footings. Very, very important that we do a good job at creating a solid foundation or solid footings if we also have those. Additionally, whenever you're thinking about concrete and where it's at, your house, also driveways and sidewalks, of course. Additionally, the floors as well. There's also retaining walls, also piers, and columns too. So this is a different option, if you don't want to have foundations, type of foundations, instead of a concrete slab foundation, you can end up having piers or columns as well. So in terms of the rebar, so as we've talked about in the class, concrete has a high compression strength. So that is if we are pushing on the concrete, right, on both sides, yet the tensile strength is very, very poor. So tensile strength is like if we're pulling something apart, right? You can think of it like a string. How do you add tension to a string? Well, you got to pull it apart, right? So concrete is very, very poor in terms of its tensile strength. What we end up doing is we add in this rebar to actually increase that tensile strength. Now, as you can see down here, this is the actual rebar, and what you're noticing here is that there is a grid system that they end up creating, and there's an overlap. Now, you might also be able to see there's little bits of wire that they end up wrapping around that basically ensures that this grid retains its shape, right? And so we're putting this rebar in here to actually increase the tensile strength of the concrete. Now, this rebar here is metal. There's also fiberglass rebar, has a whole lot lighter weight to it, and it's actually even stronger than the steel rebar. So that is some alternatives to, rebar, steel rebar. As you can also see, there are these forms set up here on the side. This is basically to make sure that the concrete will form to a certain shape. So that'll be important to know as well. All right. Here, you can see that the rebar is also used not only to increase the tensile strength, but also used to pin one structural element to an adjacent element. So in this case, we've got it where this concrete here, this footing, is actually going to connect to a wall. Is what we're going to end up having there. Also right over here, we can see that there is this upper part here, and then it kind of moves down, and then it goes down to this bottom section here, also to end up pinning those elements to each other as well. You can also see that there's that overlap with the rebar too here, and then they have like little wires in there connecting the two to make sure that it stays in place there as we pour the concrete in. Now, in terms of the concrete cost, we're going to have to take into consideration the rebar, right? So we've not only got concrete, but we've also got the rebar. Now, in terms of the actual concrete itself, it's going to be sold by volume, and it's measured in cubic yards. So cubic yard, a whole lot different than cubic feet, right? Cubic yard is a whole lot greater. So in terms of this, we need to make sure that because it's sold in cubic yards, that we're using dimensional analysis to actually ensure that everything is going to end up getting converted from cubic feet to cubic yards in the end. And so the process that you go about this could be a whole lot different. Some of y'all might end up just converting everything. So as we can see, there's inches here. You might convert everything to feet first. Then after you multiply all these out, you have cubic feet. Then you might convert to cubic yards. What you could also do is just from the very, very get-go, take this value of feet and then convert it to yards and then multiply everything together by that. All right. Anyways, I'm going to walk us through this estimation of the concrete pad cost here. So this is just for the concrete volume is what we're determining here. Now our pad size is 16 feet by 18 feet, and then we've got a 4-inch thickness. So basically we're going 18 feet, 16 feet, and then this thickness right here, or the height, is 4 inches, is what we want to imagine. So now, obviously, there's 4 inches in there. What we want is for all of our units to be the same here. And so what we can do is we can convert this from inches to feet. Very, very easy way to convert this is you basically just take the 4 inches and divide it by 12. Why do we divide by 12? Well, there's 12 inches in a foot, right? So what we end up with is 1/3 of a foot because it's 4 divided by 12. So now what we can do is we can calculate the volume. So the volume of a rectangular prism is the length times the width times height. They're replacing height with T, which is the thickness in this case. We multiply all those out. We end up with 96 cubic feet of concrete, right? Which we're thinking about that. We're probably like, that's quite a bit. Well, what we need to do is we can't actually call up the concrete company and tell them that we want this value in cubic feet. They're going to look at us very, very weird if we don't tell them a value in cubic yards. And so what we can do is we can convert cubic feet to cubic yards. Now, 27 cubic feet is equal to 1 cubic yard. So what we need to do is just use this conversion factor where we multiply 96 cubic feet by the fraction of 1 cubic yard over 27 cubic feet, because we know 27 cubic feet is equal to 1 cubic yard. And so whenever we multiply this out, we're going to see that the units of feet are going to cancel, and we're going to be left with a unit of just cubic yards. So it's going to be 3.55 cubic yards. Now, in terms of this, they only measured this to the nearest half of a cubic yard, right? It'd be very, very hard for us to end up getting exactly 3.55 cubic yards, right? So what we want to do is we want to end up rounding this up because it is over 3.5. We want to round it up to 4 because it is better to have and not need than to need and not have. So we're going to order 4 cubic yards there for the concrete in terms of the 16 foot by 18 foot by 4 inch thick concrete pad. So just as we said before, it's typically sold in increments of a half a cubic yard. So we can't order 3.55 cubic yards. We have to order 4 cubic yards because we got rounded up. Now they're saying right here that the price of this is $98 per cubic yard for the concrete. So if we multiply that out by 4, we're going to end up getting the total price in terms of our concrete pad, just in terms of the actual concrete. Now what we've got to do next is we've got to assess, okay, how much rebar or reinforcement bar are we going to need? Now, some of the rules that you're definitely going to want to make sure that you know, especially for the EOC, because they will ask you these questions for the EOC. Basically, the rules that we have for rebar is that it is placed every 2 feet. That is at max on a grid, right? So we could place it less than every 2 feet, but at the max value, we need to make sure that it is not more than 2 feet on a grid spaced apart. They also sell the rebar in 10 foot lengths. And so if we end up getting, if we're trying to span a distance of 18 feet, what we're going to have to do is we're going to have to overlap the rebar just like we saw in this right here. And then also, basically right here, just like right in here. So what we need to do is it actually has to be overlapped by a certain distance, because basically if that rebar does not overlap by a certain distance, it won't be able to actually maintain that connection or maintain its strength. And so the magical number that they came up with is that it has to be overlapped by 6 inches. Now, to also ensure that water or the elements don't end up getting into our concrete slab and affecting it, because if water does get in there, it is going to end up affecting the overall strength and how long that concrete pad is going to be able to last, because water is basically going to end up tearing down that concrete. We need to make sure that we maintain a 3-inch edge distance with our rebar. And so as you can see, there's a little bit of an overlap here, right? Or sorry, not overlap, but a little bit of a distance, edge distance that rebar is spaced away from that edge. So it's 3 inches down here, 3 inches down here. And so that is going to be where this is going to end up. This rebar is actually going to be 6 inches shorter, right, than 18 feet in this case. And so it works out pretty well, because if we end up spanning, a piece of rebar right here, right, and then also a piece of rebar right here, because there's that 6-inch overlap, it's actually going to cancel out that 3 inches up here and the 3 inches down here. And so really what we're going to need for this rebar is a 10-foot piece here, and then also an 8-foot piece of rebar right there. And so what you can end up doing is you can calculate out, well, how many 10-foot pieces of rebar are we going to end up needing for this? So if you'd like to, you can pause it, but I'm going to tell you the actual answer for that. So in terms of the 10-foot bars, what we're going to need to do is we're going to need to space one right here. Now remember, this is 3 feet away, but then we need to space it out every 2 feet. So we could go 2, 4, 6, 8, 10, 12, 14, 16. So really that's 16 inches, or 16 feet, sorry. But remember that the spacing from here to this guy, it is going to be 3 inches less is what we're going to do. And then same thing here, it's going to be 3 inches less than 2 feet there as well. But so in terms of this direction here, spanning the 16 feet, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in terms of spacing this 18-foot distance, we're going to end up using 10 there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we add those up, we're going to end up with 19 total 10-foot bars. Now what we need to do is we need to break this into their sections, right? So we're going to end up needing 6-foot sections here. And so that was for this direction. We've got the 8-foot bars here, so that's what they do first. But they end up spanning this extra, or this 18 feet here, so they get 9 of those 8-foot bars, right? So keep in mind, why is it exactly 8 feet? Well, it's because although we have this 3-inch gap here, and then we're also going to have the 3-inch gap here, we do have that 6-inch overlap that's required. And so that's why it works out where that is 8 feet there. So we're going to have 9 of those guys. And we're also going to need 10 6-foot bar sections to fill in this, right? And so in total, how many pieces of rebar are we going to actually need? It's going to be 38. So how do we get that? Because we add 10 plus 9 plus 19, that gives us 38. Some of y'all might be thinking, well, hey, we've got it where these are 6-foot pieces here, right? We can end up using the other 4-foot piece that's cut out from this. We could add 2 of those together, right? We could create this 8-foot bar. We don't really want to do that because there actually is a requirement for your rebar that you want to not have too much overlap. So if we do have those small pieces and we're consistently overlapping it, it's basically not good most of the time in codes. It could be a code violation if your rebar, if there's too many overlaps in there. I think that they have a minimum requirement. There's also a minimum requirement for how long your rebar is too. So in this case, we just want to end up using the 8-foot bar sections and 6-foot bar sections. Okay. Now, in terms of the rebar, each piece of number 4 rebar, now what does number 4 mean? It's just the diameter. It refers to the diameter, how big that rebar is in terms of diameter. So that's number 4. At the time that this presentation was created, it costs $4.78 for a 10-foot piece of rebar. I am almost certain that that price has changed probably significantly since this was created. But if we end up wanting to determine the overall cost of it, we end up taking the quantity that we need, multiplying it by $4.78, and then we'll end up with a value of $181.64. And so whenever we sum up, a cost of our concrete as well as that rebar, we end up getting a value of $573.64. So just in terms of the concrete and rebar, that's how much we're going to be looking at for the cost of this. Now, please keep in mind, though, this doesn't take into consideration the cost of labor. If we actually have a team come out and then they end up actually constructing all of this, also before we end up putting down the concrete, it's not as simple as just laying the concrete down either. We want to make sure that the soil underneath this concrete is compact. Maybe you've noticed before that there were cracks in concrete. That happens because sometimes our ground ends up settling underneath the concrete. If they didn't have it compacted enough, that'll happen. But so this $573.64 is just for the raw materials here. Other thing that we do need to add in on the sides too would be our 2x4s. So if I end up going back here, we were talking about how there's these forms right here. So we do end up needing to create the forms too. So we end up having to buy some 2x4s or 2x6s depending on what kind of depth we're dealing with. We're dealing with a 4-inch depth. And so we probably would want to end up getting 2x6s actually for the perimeter. Because remember, a 2x4 is actually just 3.5 inches in height. So we end up getting a 2x6 there. So yeah, just as they said here, the forms, that's just basically our 2x6s that we'd end up using. Also the gravel, you put gravel underneath here and make sure that that's compacted. And then also we'd have to end up getting labor, which is why, it's pretty awesome that we're learning about this, because maybe in the future, if you end up having to do a little home construction, anything in your backyard for like a shed or anything like that, you could end up building yourself and basically save yourself some money. Cost estimate, basically what we're doing here is we're forecasting what the cost is of our future project. So for even myself, I'm looking at hopefully being able to buy a house, but then also what I'm thinking about is, wow, what if I would end up building this house myself? What is just the material cost if I would end up doing it myself? So there's cost estimators out there. It's like an actual job. Now the cost estimates, they are prepared at different levels of a project. What you're going to end up doing is, first you got the conceptual design, and then you're going to be like floating the idea, okay, well, how much is this going to cost? Obviously this is not going to be too accurate at this point for the actual conceptual design. But then once we start to create the construction documents, we get a little bit more formal with the actual build or the construction that we're going to be doing. We can get a little bit more insight. Okay, this is what it's going to actually cost. The construction documents are going to be formed by our civil engineers, and so we're going to get a better idea how much it's going to cost. And then there's also a bid phase. Now this is after we have those construction documents created. Basically what you can end up doing is you'll end up sending these out to, like, let's just say 3 different companies, right? Company A, Company B, and Company C. They're going to end up all giving you different bids, which is going to basically be how much it's going to cost in the long run for them to end up buying all of your materials, and then also for them to actually end up, constructing everything, including like the labor rates, also the cost of using their equipment. Also, if they subcontract anything, it's going to include all the quotes for that, and then also the indirect costs, right? Of course, they're not going to just end up charging you what the material cost is and the labor rates, right? They're going to end up also charging you a certain value just so that they can end up making profit from this. And so these cost estimators, they'll end up using cost estimation software to kind of get an idea of what it's going to end up costing. Now those cost estimators, they perform those cost estimates. They're going to specialize in developing cost information for building projects. Obviously it takes a whole lot of calculation to be in this, but just as we said before, there is software that helps you out. And this is a position required in the construction industry, so that we can get a pretty good idea of how much it's going to cost. It's highly, highly important because, whenever we get to the bid phase, if you can get a pretty low value for what it's going to cost, then they might end up going with you for that particular project. So these are going to be employed by either an owner, the project manager, a construction contractor, or also a design professional. So it could be discipline specific. So like somebody for electrical, structural, they would end up going through a cost estimator for that. Okay. So just a little recap. As we said, this is concrete estimating. We're trying to determine how much a concrete pad would cost to construct. And then also, just in terms of the raw materials, basically is what we were focusing on. But keep in mind, you are going to have to pay for labor for other people to do the job for you. So Spark Notes review, remember, concrete pad consists of not only just the concrete, but also that reinforcement bar. In terms of the reinforcement bar, there are 2-foot spacing between rebar max. We also need to ensure that if we have multiple pieces of rebar spanning a particular direction in our concrete pad, there does need to be a 6-inch overlap, and there also needs to be a 3-inch distance between the edges for our rebar. But anyways, hope that that was helpful. You'll definitely see this on the quiz on Friday. And also, as I mentioned before, please make sure that you're taking into consideration, okay, what if we would end up applying this to our model house? How would we do it? How would we create the forms? What size of forms are we going to end up needing? How are we going to do this? That's what I want you all to be thinking about, because as I return, there's a pretty good chance that we might end up also doing this little concrete pad as well for our model house. But anyways, let me know if you got any questions. I will see you all. Bye-bye. Take care.